Hello Math 109 students. This is part 2 of the video to help you with the back half of chapter 6, section 6.3 through 6.8. Just going to go through some of the homework problems to begin with, some that we haven't covered yet in the first video, although these will cover concepts that were covered in the first video. So kind of going to go a little bit quick through them because we've already covered the concepts. So changing this exponential statement to an equivalent log statement. So remember that log means the exponent on something. So the exponent on what in this case? The exponent is on the 8. So log base 8, that means the exponent on 8 that gives you 64 is 2. The log has to always equal the exponent of the exponential. And that is our answer. So if we want to type that in, let's go to, let me show you, I can show you a little shortcut trick to type this in. You can just type log, and then if you do the underscore, then it'll go down to that subscript. So log base 8 of 64 equals 2. That's one way we could type it in. Another way would be to type log, and then what? Is there a subscript? Yeah, here's a subscript. Here's a button that will give you a subscript so that you can type the small 8 as a subscript on the log. That's another way you can get that subscript on there. All right, let's go to the next one. Okay. This will be log base what? Log base A of 6.8 equals 3. The next one involves E, the natural number. Okay, so we would say log, well, this isn't really what we would do. I'm just going to go through the thought process, but then show you the final answer. We would say log base what? The exponent on what? The exponent on E. That gives you 11 is x, but that's not how we do it. We, instead of saying log base e, we don't say log base e, we say something that means log base e, which is ln. That means log base e. That whole log base e is wrapped up in those two letters, ln. So ln, which means log base e, the exponent on e, that gives you 11, so ln 11 equals x. The exponent on e that gives you 11 is x. Remember, the log has to always equal the exponent. All right, next we are given a log, and we're going the other way. We want to rewrite the log as an exponential. So remember, log means the exponent on something. The exponent on 9. So 9 is going to have an exponent on it. And what is the exponent? The exponent is what the log is equal to, 4. 4 is the exponent on 9. That gives you 65/61. That's how we write that as an exponential statement. So let me go type that in to show you a little shortcut about how to type that in. We can say 9, and then if you do the little carrot top or the little house top, rooftop button, which for me and on my keyboard is the, if I hit Shift 6, it's the alternate thing I can do for the 6 button, and it gives me the superscript function. So it lets me type in an exponent. So 9 to the 4th equals 65/61. But another way you could do that is you could type 9 and then the superscript button is right here. So you can do that, and that is another way to get that done. And that is well done. Again, we're changing a log to an exponential, so the exponent is on A. A is the base of the log, and A is the base of the exponential. 8 is the exponent on the base, and it gives you 6. This time we're given an ln. Remember that ln means log base e. Ln means the exponent on e. So e is the base of the exponential because e is the base of ln, understood to be the base of ln. What is the exponent on the e? It's what the log is equal to. It is the x. X is the exponent on the e, and that gives you 2. So that is my exponential form. All right, the next couple were evaluating logarithms without using a calculator, which I already showed you how to do in the previous video, so I skipped a couple of them. But this one looked a little bit more tricky, so I wanted to go over this one with you. So log base 2 of the 8th root of 2. Okay. If you will just change the 8th root to an exponent, it will make this a very easy question. How do you rewrite the 8th root of 2 as an exponent instead of a root? You can rewrite the 8th root of 2 as 2 to the 1/8 power. And now it's pretty easy, because this means the exponent on 2, that gives you 2 with an exponent of 1/8. The answer is in the question. The answer is 1/8. Or another way you can think about it is a log base 2 and an exponential base 2 cancel each other out. So the answer is simply 1/8. This one looked a little tricky, also kind of like the last one. You probably already can do this one just from the last one, but ln, just rewrite the 10th root of e, write it as e to the 1/10, and now it's easy, because ln means the exponent on e. And so we have e to the exponent of 1/10, so the answer has to be 1/10. Or another way you can think about it is ln and e cancel each other, so you just get 1/10. The next problem involves solving a log equation, so I just want to go ahead and pause and take this time to introduce you into how to solve exponential equations and log equations. So this will be solving exponential and log equations. All right, so the first ones I'm going to do are going to be exponential equations. So let's say we have 3 to the x equals 9. I'm just going to give you several examples. All right, let me do another one. How about that? Okay, so number one is actually, you can do that one in your head. You kind of already know what x has to be. X has to be 2. So if you can do it in your head, fine, do it in your head. But if you can't do it in your head, then you're going to have to use algebra skills. And you already have a lot of algebra skills by now in your mathematical career, but you got to add another tool to your bag. And the tool that you're going to add to your bag is how to get rid of an exponential base. Like if you want to get rid of something to get the variable by itself, you always have to do the opposite of whatever is with the variable. So like if it was x plus 5 equals 3, I'd have to get rid of the plus 5 by subtracting 5. So you're always doing the inverse operation of what is there in order to get rid of what you want to get rid of. So if we want to get rid of that exponential base 3, we got to use the inverse of an exponential base 3, which is a what? Hopefully you kind of know that by now. The inverse of an exponential base 3 is a log base 3. And as long as I do the same thing to both sides of the equation, I'm good. So log base 3 and exponential base 3 cancel each other out. And I'm just left with x on the left side. I'm left with x by itself, which is what I want. And then log base 3 of 9, the exponent on 3 that gives you 9, that is 2. And if you didn't know that, you could go to the calculator and type in log base 3 of 9, and it would give you the answer there. Moving on to number 2. This one you can't do in your head because we don't know what exponent I could put on 3 to give me 14. It's not just some good old integer whole number answer. So this is where I have to do the extra algebra skill that we just learned. To get rid of that exponential base 3, I'm going to do a log base 3. And if I do it to one side of the equation, I got to do it to the other side of the equation, so that cancels that out. And that gives me x equals log base 3 of 14. Now in Math Excel, I think they will want you to leave that as the answer and just to type that in as the answer. But maybe you might want to sometimes be able to get the decimal approximation of that answer. And so if you want to get the decimal approximation of that answer, you're going to have to use your calculator and type it in. So if we want to do log base 3 of 14 in our calculator, we will go to Math and then click all the way down on the Math menu to log base. And when you do log base, it lets you put in a base, which is 3. It lets you put in a logarithm, which is 14. And you get a good old decimal approximation, 2.402. So if we want to maybe round to the nearest 100th, then it would just round to 2.40, or I can just leave it as 2.4. So Math Excel, if Math Excel says to type an exact answer using logs as necessary, then you're just going to type in log base 3 of 14. But if at some point you have to give a decimal approximation, then you type in your calculator to do that. All right. Next problem. Okay, we're trying to get x by itself. Don't forget the other algebra skills that you've had for a long time. First, we want to get rid of that plus 2. We'll get rid of that first by doing what? By subtracting 2 from both sides. And that gives me 3 to the x minus 5 equals 35. Now, how do I get rid of that exponential base 3? I use what we just learned, log base 3. And I got to do the same thing on both sides of the equation. So that gives me x minus 5 equals log base 3 of 35. Again, if you have to type in an exact answer, just leave it as log base 3 of 35, and don't type it in your calculator. However, if you're trying to get a decimal approximation, then you can go ahead and type this in your calculator to get the decimal approximation. We also have to do one more step to get our final answer, and that is to get x by itself from here. You know what to do. Add 5 to both sides. So that gives me x equals, you can't add the 5 to the 35 because it's not part of that log. You just got to leave it separate. Log base 3 of 35 plus 5. That is the correct answer. If you want to type in an exact answer into Math Excel, if it needs that, then that's what you'll type in. If you want to do a decimal approximation, we will just type that as it is into our calculator. I'll show you that again. Log, let's see here, what is it? Log math. Go to log base. Go to log base, and what was our base? Log base 3 of 35. Log base 3. And then 35 goes in that parentheses. And get out of the parentheses so you're not part of the log anymore. And then do plus 5. And that gives us our decimal approximation, which is 8.24. So just be aware of what Math Excel wants you to type in. Well, let's take care of the fourth example I wrote up here. So we want to get rid of that minus 1 first, and I do that simply by adding 1 to both sides. And that gives me 2 times 7 to the x over 4 equals 6. Now, here you might be tempted to multiply the 2 with the 7 and get 14 to the x over 4, but you can't do it. You can't multiply unlike bases when their exponents aren't the same. The 2 doesn't have that exponent on it. The x over 4 is only the exponent for the 7, not for the 2. So you can't multiply them together. So get rid of the 2. Instead of multiplying the 2 with the 7, get rid of the 2. How would you get rid of that 2? Well, what is the 2 doing? It is multiplying. So how do you get rid of it? You divide it. So we divide that 2 to get rid of it. And that gives us 7 to the x over 4 equals 3. Then what do? Then you will get rid of that exponential base 7 by doing what? Log base 7 on both sides. That cancels that out. So that just leaves me with x over 4 equals log base 7 of 3. And then the last thing to get rid of is that 4. What is that 4 doing? That 4 is dividing with that x, so how do we get rid of it? We multiply by 4 on both sides. So cancels that out. And we get x equals, just put the 4 in front of the log base 7. Definitely don't multiply the 4 with the 3 because the 4 is not part of that log. So just keep them separate. Just put the 4 in front of the log base 7 so that it's multiplying with the log base 7 of 3. And this is my answer to type it in as an exact answer. We could get a decimal approximation simply in our calculator if we want to. All right, let's do these. These are also exponential equations, trying to get x by itself. So what do we do first on number 5? The 3 can't multiply with the 10. I want to get rid of the 3 by dividing that 3 on both sides. That gives me 10 to the 2x equals, I'm just going to leave it as 1,000 over 3. I could get a decimal approximation, but let's leave it exact for now. Then how do I get rid of the exponential base 10? I do log base 10 on both sides. But remember, to do log base 10, that's the same thing as a common log, so you just put log and you don't even have to write a base. If you don't write a base on the log, it's understood to be a base 10. All right, and so we just put the common log there, and that cancels that out. And so that leaves me with 2x equals log of 1,000 over 3. And then divide both sides by 2, and we're done. X equals log of 1,000 over 3 all over 2. Or you might see this written as 1/2 log 1,000 over 3. That's the same thing. If you want to get a decimal approximation, again, you could type it all in your calculator to get that decimal approximation. All right, here, what are we doing first? We're getting rid of that -7 by adding 7 to both sides. And that gives me 3e to the 2x equals 42. Then I divide both sides by 3 to get rid of that 3. And I get e to the 2x equals, what's 42 divided by 3? That's going to be 14, I think. Yep. Then I want to get rid of that exponential base e. How do you get rid of an exponential base e? You do a log base e, but remember, you don't write log base e, you write ln, which means log base e, natural log. And that ln cancels out the e. And we're left with 2x on the left side equals ln 14. Okay. And then we simply divide both sides by 2. And we get x equals ln 14 over 2. Or you could say 1/2 ln 14. Again, we could type these things in our calculator to get a decimal approximation. Let me just show you how to type that in. ln 14 over 2. There's an ln button right here. ln 14, close parentheses, 14, close parentheses, and then divide that by 2. So that's not the same thing as ln 7, because dividing by 2 is not part of the ln. It's separate from it. And then if you want to type in the other one, log of 1,000 over 3, log, you just type the log button. You don't even have to do log base. The log button here means the common log, which is log base 10. 1,000 over 3. And then what, divided by 2, then divided by 2. And that would be the answer to that one as a decimal. Okay, all those problems before were all exponential equations. So now let's do some log equations. I don't remember what number I left off with, so I'm just going to start with number 1 for the log equations. Okay, number one, we're trying to get x by itself. You could think of this kind of in your head. This means the exponent on 2 that gives you x is 8. That means 2 with an exponent of 8 on it should give you x. So 2 to the 8th, that's what x is. But if you couldn't work through it like that in your head, use the algebra skills that we are talking about. And that is to get rid of a log base 2, you're going to use the inverse of a log base 2. What is the inverse of a log base 2? It is an exponential base 2. So remember, when we're solving exponential equations, we have to get rid of that exponential. We're going to use a log to get rid of that exponential. And when we're doing log equations, to get rid of the log, we're going to use an exponential. I don't know if I said that right. Let me say it again. When you do exponential equations, when you solve exponential equations, you're going to have to use a log, most likely, to solve it. And when you solve log equations, you're most likely going to have to use an exponential to solve it. So how can we use an exponential to invert that log base 2? Well, we do something, a really fancy word. You sound really smart when you say it. The word is exponentiate. Exponentiate both sides. So what does it mean to exponentiate? It means you write a big exponential base 2 on both sides. So what it does is it makes the log base 2 of x become the exponent on the 2, and it makes the 8 become the exponent on the 2. And what happens is the exponential base 2 and the log base 2 cancel out, which leaves you with x equals 2 to the 8th. And you could leave it as 2 to the 8th, or you could maybe get the answer in your calculator, although it's going to be a fairly large number. So you just have to be aware of what does Math Excel want me to type in. Do they just want me to type in 2 to the 8th? Or do they want me to, I guess it ain't that big, is it? Or do they want me to write 256? So, that's how we would solve that one. Let's do this one. What do we want to do first here? Again, don't forget your previous algebra skills. We want to get rid of that plus 3. And how do we do it? We subtract 3 from both sides. And so that gives me log base 2 of x minus 4 equals 2. And then I'm going to exponentiate both sides with a base 2 to get rid of that log base 2. That cancels that out. And that leaves me with x minus 4 on the left side equals 2 squared, which is 4. And then I will add 4 to both sides to get rid of that minus 4. And my final answer is x equals 8. All right, there is a kind of an aggravation about logs, and that is that sometimes you can get answers for x that aren't real answers. They can be extraneous solutions, so you do have to kind of think about plugging the number back into here. But it's not a whole lot you got to do. When you don't have to like type it in and type the whole thing in. Just think about if you plug 8 back in for x right here. The only thing that could make this go wrong is if it makes the logorand become anything but a positive number. If it makes the logorand become 0 or negative, then it's going to mess things up. So if I put 8 in, 8 minus 4 is still positive 4, so that's fine. Nothing's going to be harmed by that. But let's say if I had to put in 1 here, 1 minus 4 would make this negative, and so it wouldn't screw it up. Or if I had to put in 4, 4 minus 4 would make this 0, that would mess it up. But the 8 is fine. All right, let's do number 4. What do we do first? We get rid of that minus 1 by adding 1 to both sides. We get 3 log base 7 of x over 5 equals 10 plus 1 is 11. Then we divide both sides by 3. And that gives us log base 7 of x over 5 equals 11 thirds. Just leave it as 11 thirds instead of getting it as a decimal there. And then get rid of the log base 7 now. I should put parentheses right here. Get rid of the log base 7 now by exponentiating with a base of 7 on both sides. So this gives me x over 5 equals 7 to the 11/3. And now get rid of that 5 on the bottom of the fraction by multiplying both sides by 5. And that gives me x equals, just write the 5 in front of the 7 to the 11/3. The 5 does not multiply with the 7 because they are not like bases. They don't have the same exponent. You can't multiply them together. You just got to write the 5 separate from the 7. So just write it in front of the 7. That would be the best way to write it. And you can leave your answer like that, or you could get it as a decimal approximation in your calculator if you want to, but I'm just going to leave my answer like that. Let's do number 5. Question: is that -1 part of the log or not? It is not, because it's not written in parentheses with the 3x. Okay, if it was written like this, then the -1 would be part of that log. So I would not get rid of the -1 until I get rid of the log. But because it's not written in parentheses, I'm going to get rid of the -1 first because it's not part of the log. I'm going to go ahead and get rid of the -1 by adding 1 to both sides. And that just gives me log of 3x equals 3. And now, what's the base on this log right here? It's understood to be base what? Base 10. So then to get rid of that log, I'm going to exponentiate with a base of 10. Cancels that out. It gives me 3x equals 10 to the 3rd, which is, I believe, 1,000. And then I'm going to divide both sides by 3. And x will equal that, 1,000 over 3. I think I'll just leave it as a fraction instead of rounding it off. All right, let's do a couple more. Okay, what do we do here? Well, we get rid of that 3 first by dividing both sides by 3. And then that gives me ln x plus 4 equals, I think this divides evenly. 3 goes into 5 one time, and you're left with 24, so 18. And then how do we get rid of that ln? What is the base of the ln understood to be? It's understood to be e. So you will exponentiate both sides with a base of e. So that gives me x plus 4 equals e to the 18th. Then I'll subtract 4 from both sides and get my final answer. X equals e to the 18th minus 4. And again, you could type that in your calculator. I'll just show you how. I believe this is going to be way too big of a number, but here is your e. You have actually 2 different options for e. This gives you e to a power, and this just gives you plain old e, so it doesn't matter. We're doing e to the 18th, so it doesn't matter which one we do. I'm just going to do the plain old e and then click the exponent button, e to the 18th, and then minus 4. And that gives me a pretty darn big number. So we could list our answer like that, or we could maybe leave it as e to the 18th minus 4. And I think that's as far as I want to go on this part 2 video. I will see you again in part 3.